Paper is one of humanity's greatest inventions. It carries our thoughts, preserves history, enables education, and even wraps our food. From the ancient scrolls of China to the printing of millions of newspapers every single day, paper has shaped civilizations. But behind every sheet of paper lies a fascinating journey. A journey that begins in the forest, travels through mega factories with machines hundreds of meters long, passes through the roaring engines of printing presses, and often returns again to the cycle of recycling plants to start its life anew. So let's unfold the story, sheet by sheet, of one of the most important materials in human history: paper. Before we dive into the fascinating journey of paper, I'd like to invite you to join our community here on YouTube. If you enjoy learning about how everyday things are made and discovering the hidden stories behind them, make sure to hit the subscribe button and turn on the notification bell. That way, you'll never miss our future videos. Our story begins deep inside managed forests. Contrary to what many think, most paper does not come from old-growth forests, but from sustainable tree farms. These are carefully planted and harvested areas designed to balance industry needs with environmental protection. Workers select trees, mostly softwoods like pine and spruce, or hardwoods like birch and eucalyptus, because of their strong, fibrous structure. Once cut, the logs are stripped of bark, chipped into small pieces, and transported to massive pulp mills. Here begins the transformation. Wood is made of three key components: cellulose fibers, the building blocks of paper; lignin, which binds the fibers together; and hemicellulose. To make paper, we need to extract the cellulose. The chips are cooked under high pressure with chemicals in giant digesters. This process, called the Kraft process, dissolves the lignin and separates the cellulose fibers. What's left behind is a brown, mushy mixture called pulp. But raw pulp isn't yet ready to become paper. It needs cleaning, bleaching, and refining. Impurities like knots, sand, or leftover lignin are removed. Then bleaching agents are used to brighten the pulp, giving us the clean white fibers needed for high-quality printing and writing papers. The pulp is then mixed with water, lots of it. In fact, the pulp slurry at this stage is 99% water and only 1% fiber. Why so watery? Because it allows the fibers to flow evenly onto screens in the next stage, forming consistent sheets. This is the foundation. From towering trees, through chipping, pulping, and bleaching, we now have a raw material ready to be shaped into paper. Now comes the mesmerizing part, turning pulp into continuous rolls of paper. The diluted pulp mixture flows onto a moving wire mesh conveyor called the fourdrinier machine. As water drains away, the fibers begin interlocking, forming a wet mat. Giant suction boxes pull even more water out, and slowly, a sheet of paper starts to take shape. Next, the damp sheet passes through enormous heated rollers. These squeeze out the remaining water while drying the paper under controlled heat and pressure. It's a delicate balance. Too much pressure and the sheet becomes brittle. Too little and it won't hold its form. After drying, the paper undergoes calendering, a process where smooth steel rollers compress it to achieve the desired thickness and surface texture. This is how we get glossy magazine paper, crisp office paper, or rough cardboard, all from the same pulp, just processed differently. Finally, the finished sheets are wound into gigantic rolls, sometimes weighing up to 30 tons and stretching for miles if unrolled. These rolls are then shipped worldwide to publishers, packaging companies, and printers. At this point, paper is a blank canvas, ready to carry the next big idea. The invention of the printing press in the 15th century turned paper from a luxury into a necessity. Today, modern printing presses run at lightning speed, producing newspapers, magazines, books, and packaging on a massive scale. In offset printing, for example, inked images are transferred from a metal plate to a rubber blanket, then pressed onto paper. The paper zooms through rollers at hundreds of feet per second, each sheet absorbing precise layers of ink. Think about it. That morning newspaper you hold was just a blank roll of paper the day before. Now it's filled with photographs, headlines, and stories, brought to life by printing technology. From political revolutions to love letters, from textbooks to advertising posters, printing on paper has been humanity's way of spreading knowledge, culture, and emotion for centuries. Unlike many materials, paper can be recycled up to 5 to 7 times before the fibers become too short to bind. Recycling plants collect used newspapers, cardboard boxes, office waste, and packaging. The paper is sorted, shredded, and mixed with water to form a slurry again. Ink is removed through a process called de-inking, where air bubbles lift ink particles to the surface. The cleaned pulp is then mixed with fresh fibers for strength. This recycled pulp goes back to paper machines, forming new sheets. Some become newspapers again, others packaging boxes or even tissues. Recycling not only saves trees, but also reduces landfill waste and conserves energy. Each ton of recycled paper saves about 17 trees, 7,000 gallons of water, and enough energy to power a home for 6 months. If you enjoyed this video and want to see more fascinating journeys of everyday materials, don't forget to like, subscribe, and hit the bell icon. It really helps us grow and bring you more educational content from inside the world's most essential industries. Thank you for watching, and remember, the story of paper is also the story of us. How does a lump of soap, sitting quietly on your bathroom sink, go from raw ingredients to the tool that keeps you healthy, fresh, and ready for life? Well, today we're taking a trip inside an American soap factory, where tradition meets technology, and where every bar, every drop, has a story. Before we dive into the bubbly world of soap making, I've got a quick favor to ask. If you love learning how everyday things are made right here in America, hit that subscribe button and tap the bell. That way, you won't miss any of our behind-the-scenes adventures. And trust me, they smell a lot better than this one might at the start. Alright, let's get our hands sudsy. Soap is older than the United States itself. Thousands of years ago, people discovered that if you mixed animal fat with ashes from a fire, you could make something that actually lifted dirt and grease right off your skin. When the first settlers came to America, they didn't have fancy pumps or factory lines. Soap was made at home, in backyards, kitchens, and barns. They'd save animal fat from cooking, boil it with lye made from wood ash, and pour it into wooden molds. It was rough, harsh on the skin, but it worked, and it was precious. Fast forward to today, the chemistry is the same. Soap works by surrounding dirt and oils, locking them in tiny bubbles, and carrying them away with water. But the way we make it? That's where modern American factories take the stage. Let's step inside one in Cincinnati, Ohio, a city that's been called the birthplace of some of America's biggest soap brands. The moment you walk in, you notice the smell. Not overpowering, but soft and layered. Hints of lavender, citrus, maybe even vanilla. Somewhere in here, a batch of fresh linen is being bottled, and across the hall, giant vats of bar soap are cooling into perfect blocks. The place is alive. Stainless steel mixing tanks hum quietly. Conveyor belts glide past, carrying rows of bars. Workers in clean uniforms check gauges, take samples, and keep the rhythm moving. This is soap making at American scale, but with the same care you'd find in someone's kitchen, just multiplied thousands of times over. Soap may seem simple, but it starts with a carefully chosen mix of fats or oils and an alkali, usually sodium hydroxide known as lye. In this facility, huge tanks hold natural oils like coconut, olive, and palm, each adding its own personality to the final product. Coconut oil makes the soap bubbly and light, olive oil gives it a creamy lather, and palm oil adds firmness so the bar lasts longer. These ingredients arrive in big drums, labeled and checked for quality. Workers in safety gear take samples, making sure every oil is pure, clean, and exactly what the recipe calls for. This is where science meets craftsmanship. Oils are pumped into giant stainless steel kettles. They're taller than a person and can hold hundreds of gallons. Meanwhile, the lye solution is prepared separately, dissolved in water with precision. Once both are ready, the lye is slowly mixed into the warm oils. The moment these two meet, a chemical reaction called saponification begins. It's the magical transformation that turns liquid oils into solid soap. The mixture thickens like pudding, changing color as it comes together. The head soap maker checks the texture by hand. Yes, even in this industrial setting, human skill matters. Too thick, too soon? The batch might not cure properly. Too thin? It needs more time to react. This is where the personality of each soap comes alive. Essential oils for fragrance are measured out. Lavender for relaxation, peppermint for a fresh wake-up, eucalyptus for a spa-like feel. Natural colorants like clay, herbs, or mineral pigments are sprinkled in. In some batches, they add gentle exfoliants like oatmeal, coffee grounds, or sea salt. It's a moment of artistry, swirls of color, ribbons of fragrance, and a sprinkle of texture, all mixed just enough to look beautiful, but not so much that it loses its handcrafted charm. Once the soap mixture is ready, it's poured into large block molds. Think of them like giant bread pans, except instead of baking, these molds will hold the soap while it cools and sets. Workers spread the top smooth with long metal spatulas, making sure there are no air pockets or uneven spots. Here, time is the secret ingredient. The soap needs to rest for about 24 hours to fully harden enough to handle. Some artisanal batches are even wrapped in blankets to keep them warm overnight, allowing the saponification to finish evenly. The next day, the molds are opened, revealing massive slabs of soap, creamy blocks that smell amazing. These slabs are pushed through a wire cutter, slicing them into perfect, uniform bars. It's oddly satisfying to watch, like cutting a giant block of cheese but softer and smoother. Each bar is then inspected by hand. Any rough edges are trimmed, and imperfect pieces are set aside for reprocessing, ensuring nothing goes to waste. Here's something most people don't know. Soap isn't ready to use right after it's cut. It needs to cure. That means it sits on open-air racks for 4 to 6 weeks, allowing excess moisture to evaporate and the soap to harden. Walking into the curing room is like stepping into a dream. Rows and rows of neatly stacked bars, each aging like fine wine. This step makes the soap milder, longer-lasting, and better for your skin. Patience really does pay off. Once fully cured, the bars are ready for their final transformation. Workers wrap them in paper, boxes, or biodegradable film, often with beautiful designs that reflect the scent and style. Labels are applied with pride, made in America, all natural ingredients, handcrafted. Every package tells a story, and for small American soap makers, that story is often about community, sustainability, and quality you can trust. Finally, the soap is packed into boxes and sent to stores, hotels, and homes all over the country. Some will end up in luxury spas, others in small town markets, and many will arrive in online orders, each bar carrying with it the care, craftsmanship, and tradition of American soap making. Tomorrow morning, when you wash your hands, pause for a second. Think about the journey that little bar has taken. From fields where soap is part of your daily routine, but it's also a small, fragrant reminder of the work, care, and history behind everyday things. And hey, if you love seeing the hidden stories behind what we use every day, hit subscribe, ring that bell, and join me for the next journey. Because the world is full of amazing stories, and I can't wait to share them with you. Every part is tested, every function verified. From welding sparks to rolling off the line, it takes over 40 hours to build a single unit. Made in America, built to last, trusted worldwide. Today we take you inside John Deere's advanced manufacturing facility in Waterloo, Iowa, to see exactly how these machines are assembled from start to finish. No fluff, just steel, skill, and smart technology. This is how it's made. John Deere tractors. Before it became a global leader in agricultural machinery, John Deere was just a blacksmith. In 1837, in the small town of Grand Detour, Illinois, Deere invented something simple, but revolutionary. A polished steel plow that could cut through the thick, sticky soil of the American Midwest. Farmers were struggling with traditional cast iron plows that clogged easily. Deere's innovation didn't just solve a problem, it changed agriculture. As America expanded westward, so did demand. Deere moved operations to Moline, Illinois, harnessing water-powered factories and railway connections. The company grew fast, not just in size but in reputation. By the early 1900s, John Deere had become synonymous with reliability. In 1918, the company built its first tractor, the Waterloo Boy, a name that still echoes in Iowa, where many John Deere tractors are made today. Through 2 world wars, the Great Depression, and the rise of precision agriculture, John Deere kept evolving. It introduced diesel engines, power steering, 4-wheel drive, and eventually, onboard GPS and autonomous navigation. Today, John Deere isn't just building tractors, it's building smart machines that help feed the world, while staying true to a simple idea. Tools should work as hard as the people who use them. From a one-man forge to a global powerhouse, the journey of John Deere is built on steel, sweat, and something stronger than both: trust. The making of a John Deere tractor begins long before any welding sparks fly. It starts with materials. Thousands of tons of high-grade carbon steel, delivered by rail to the company's manufacturing hub in Waterloo, Iowa. This is the backbone of every tractor, tough, dense, and engineered to handle decades of heavy field work. Steel coils are unloaded, stored, and later laser cut into precision shapes, everything from chassis frames to transmission housings. But steel is just the beginning. Massive tires made from reinforced rubber are shipped in from partner plants. Hydraulic cylinders arrive pre-tested, ready to power lifting arms and steering systems. Aluminum components for the cab interior are pre-molded and lightweight, chosen to balance comfort with fuel efficiency. Electronics are sourced globally, but calibrated locally. Each tractor contains dozens of sensors, control units, and wiring harnesses, all built to survive dust, mud, vibration, and temperature extremes. At the heart of it all is the PowerTech diesel engine, made in-house by John Deere. Once the raw materials arrive, the first major transformation begins, turning flat steel into a tractor's structural backbone. At the chassis fabrication zone, sheets of carbon steel are fed into CNC-controlled laser cutters. Guided by digital blueprints, the lasers slice each piece with sub-millimeter precision, forming mounting plates, axle housings, and load-bearing crossmembers. These components are then moved to a series of robotic welding stations. Here, mechanical arms grip, align, and fuse them together using MIG welding, a method that delivers strong, consistent seams with minimal distortion. Each frame is designed to handle over 20,000 pounds of torque and field stress, which means no tolerance for error. After welding, the chassis enters a shot blasting chamber, where high-speed steel grit strips away imperfections, preparing the surface for paint. Next is the powder coating process, a signature green finish applied electrostatically. The coated frame is baked in industrial ovens, curing the paint into a weather-resistant, chip-proof armor. It's more than color, it's protection for decades of hard use. As the frame cools, it passes through a final inspection bay. Cameras and laser scanners measure key dimensions against digital models, while technicians verify alignment points for axles, engines, and cabin mounts. When it leaves this stage, the chassis is no longer just a piece of metal. It's the skeleton of a working machine, strong, straight, and ready for power.